This is for class 11. Class 11. Stationary waves in a string fixed at both ends. I have selected this topic because I want to give a what its practical application. I want to show you the practical application. No, no doubt, I have no knowledge in music. I have no knowledge in music, but as the theory given in the stationary waves, I will try to explain you the how does the practical application of stationary waves. So this is a small theory. A string clamped at the two ends. If the wire is plugged in the middle, transverse waves travels along it. They reflect from the ends. These identical waves travel in opposite directions, gives rise to stationary waves. That means in guitar or in violin, you will find that the string is fixed at two ends. The string is fixed at two ends. Now, suppose this is the wave and it reflects and it's move in this direction. So these two waves will superimpose. These two waves will superimpose and it will form like this. These two waves will superimpose and form like this. That means, first of all, the main basic theory is any vibrating object, any vibrating object produces a sound. So here, when the string vibrates, it will produce a sound. So what will be the frequency of the string that I am going to show you, and as well as its practical application. So a string clamped at two ends, if the wire is plugged in the middle, you have plugged this wire in the middle, transverse waves travel along it. If you plug in the middle, it will be, the shape will be somewhat like this. The shape will be somewhat like this, but I have given it just a general theory. uh, Travels along it and it gets reflected in the opposite direction, gives rise to a stationary waves. This is the stationary waves, and the speed of the transverse wave on the string will be V is equal to root over tension divided by, this is m, is the mass per unit length. T is the tension of the string. This T is the tension, that is the tension in the string, and m, it is the mass per unit length, mass per mass per unit length of the string. This is the mass per unit length of the string. This is the mass per unit length of the string. Now, first of all, I will go to the first mode. In the first mode, the string is plugged in the middle and released. So here you see length, this is the length of the string, this is lambda by 2, because we know the wavelength, we know that the wavelength, this is the wavelength. So this is half, only this portion, so it is half. So your lambda 1 will be equal to 2L, twice L, your lambda 1 will be twice L, because 2 here, your lambda will be twice L. Now, we know that frequency, velocity of the sound, that is equal to frequency into wavelength. So V by lambda, this is the frequency. And when we place the velocity of the transverse wave, we get, this is the result, and this is the minimum frequency with which a string can vibrate is called the first harmonic. This is the minimum frequency with which the string can vibrate is called the first harmonic. And your second mode of vibration, if the string is placed in the middle and plucked at 1 by 4th the length, then it vibrates in two segments, and here you see the frequency doubles, and this is called second harmonic or first overtone. And this is the third mode of vibration. If the string is placed at one third of its length from one end, plucked at sixth the length, it will vibrate in three segments. And here you see the frequency, it becomes thrice, that means third harmony. That means here you see the frequency of the string increases. Here you see this is the fundamental frequency, that means the first harmonic. And second, here you see the frequency has increased twice. And here again you see the frequency has increased thrice. So how this is applicable in practically? So let me give you an example of guitar. Here you see the guitar. Here you see the guitar. Is the string. I am taking only one string. This is the upper string. Here it is fixed at two ends. So here you see it is fixed at two ends. Fixed at two ends. So this is the length of the string. It is fixed at two ends here, this and this, it is the fixed at two ends. Here you will see it is fixed at two ends, this and this, it is fixed at two ends. I am considering only one string here, this is one string. Now, if I, here it is, if the string is plucked in the middle, so uh, the rough idea I am taking, this is the middle, I just release it. So here, this is the minimum frequency that is with which a string can vibrate, and it is called the first harmony. So what does a guitarist do? He knows what is the frequency of the string. So first of all, he will give tension to the string. He will give tension to the string and hear the sound slowly so that the required frequency is set in the string. So the required frequency is set in the string. When the required frequency is set in the string, so when you pluck in the middle, you will get pluck in the middle, then your vibration, this will be the your vibration, that is the vibration, it is the first harmony. Now in the second mode, what it has told you, pressed in the middle and plucked at one fourth the length, then it vibrates in two segments. Press in the middle. So I am taking a rough idea from here to here. I am taking a rough idea of the length of the string from here to here. I am pressing at the middle. So this is somewhat in the middle. So this is somewhat in the middle. This is somewhat in the middle. And now I divide it rough into four parts, say one, two, three, and four parts. Now I pluck here. I press here, and now I pluck here. I one fourth. Here I pluck here. Yeah, I pluck here. So here you see the frequency becomes twice. Originally here the frequency at the middle it was this. Now I just press in the middle. Say I take a rough idea that this is the middle here. I am not a I do not know about the music, but as per the theory, what they have explained here, I am going to give you the what is its practical application. You press in the middle. You press in the middle, and now divide it into four equal parts. That is one, two, three, and four. Now you plucked where? That is one fourth of the string, and plucked at one fourth of the string. Yes, this is half. Huh? You pluck at one fourth of the string. So here what happens? Your frequency becomes twice. Now in the third case, that is the third mode, if the string is placed at one third of its length from one end, that means one third. This is the length of the string. A rough idea. So you one third, one, two, and three. Rough idea. So I am pressing here, and now I divide it into six equal parts. One, two, three, four, five, and six. Now, if I pluck at one sixth of the length, that means if I pluck at one sixth of the length, if I pluck at one sixth of the length, then your vibration becomes thrice, because this wire is not tuned. So you might have heard a different sound. But this is what happens. That means your frequency it becomes size when you press one third you press your finger, and then you divide it into six equal parts, and then you press in the plug here, you will get the frequency that is thrice the frequency. So what happens that when the frequency increases, that means when the frequency increases, your sound becomes more clear. So a person who is singing at a high scale, that means his frequency is high. That means here this is a high frequency. When a person is singing at a high frequency, that means the sound is more clear. The sound is more clear. So in this way, the uh, uh, the frequency is increased. In this way, the frequency means, first of all, the guitarist, he will fix the frequency of that string. He knows what is the frequency of the string, he knows that, and he will give tension to the string, and he will fix the frequency of the string, and then you will get this first harmony, and then your second harmony, that means frequency. Suppose suppose this, I do not know about music, but let us suppose the frequency of the frequency of sa is 256 hertz. Let the frequency of the sa is 256 hertz. But when in your second harmony, twice the frequency means 256 into 2, the vibration will be 256 into twice time. And your third in the third harmony, your vibration of the string, that means your vibration of the string will be three times. That means three times your fundamental frequency, harmony frequency. That means this is at the that means this is at a high scale. And what is the advantage of a high scale? When it is at higher frequency, you get the sound clear. So this is how a musical instrument are set, and how the musician plays his guitar. Thank you.